Hey, today we're going to continue our conversation about linear functions. In this case, we're going to be looking for the equations of these lines. Now, we have already talked about this notation f of x equals mx plus b. The m is the defining slope and the b is the y-intercept. Now, if we replace our function notation with a dependent variable y, we get an equation that tells you the relationship between x and y in this linear fashion with the slope m and the slope b. So for a given set of points, what is the equation of the line that goes through those points? So we need some more information. We need to know what the slope is of the line, and if we have the slope, then we can use a point. So this is enough information because the slope is determined by the change in y over the change in x. So this is just a slope formula. And so we're just bringing it over here. The x and y are generic variables, and the x and y, x1 and y1 are specific points on the line. So if we have that information, we can find the equation of a line. Let's do an example here. So if we find the equation of the line containing the points 2, 3, 1, negative 4, the first thing we need the slope. So what is the slope of this line? Well, any 2 points will do. We have 2 points available to us. We find the change in y over the change in x. So the change in x be 1 minus 2, change in y negative 4 minus 3. Now be careful with the negative sign. You get negative 7 over negative 1. This line has a slope of 7. Okay, once we have our slope, we just need a point. So pick any point. How about this one right there, 2, 3. So we use our equation, y minus y1 equals m times x minus x1. So this is our slope point equation, point slope equation. So we use the y value. So in this case, it's 3. And our x coordinate is 2, so x minus 2. And this is an equation of the line that passes through the points 2, 3 and 1, negative 4. But it's not in point slope formula, it's not in slope intercept form. It's kind of muddled here of how x and y are directly related. So we want to go a little bit farther, do a little bit more algebra here. So we want to distribute that 7, so we get a minus 14. We want to bring the 3 over to the other side as a positive. And our final simplification here, we get 7x minus 11. So 7x minus 11 is a line that passes through the point 2, 3 and 1, negative 4. You should check these numbers. So if you plug in a 2, you get 14 minus 11 is in fact 3. If you plug in a 1, you get 7 minus 11, which is a negative 4. So in fact, this is the formula for the function that passes through those 2 points. Given a line, what is a parallel line that goes through a certain point? For instance, in this example right here, here's a line 2x minus 3. It has a slope of 2, a y-intercept of minus 3. Find a parallel line that actually goes through the point 0, 4. And here it is 2x plus 4. Parallel lines have the same slope, but different y-intercepts. Now you don't have to know exactly this y-intercept. Any point on that line would be sufficient because we have the point slope equation. If we have a point and the slope, then we can find the equation of the line. Now, if we're looking for a perpendicular line, so here's that line again, y equals 2x minus 4. Now, if we want to find the perpendicular line to y equals 2x minus 4, we have to find a line whose slope is the negative reciprocal of that first line. So what we say is m1, that's the slope of the first line, times the slope of the second line is equal to negative 1. That would cause them to have a negative reciprocal relationship. So slope of 2, any line that has a slope of negative 1/2 will be perpendicular to a line with slope of 2. Let's look at an example. So write the equations of the line parallel and perpendicular to the graph of 4y minus x equals 20 and containing the point 2, negative 3. This is going to need several steps. So let's start out with the parallel steps. So the parallel, we need to know the slope that we're working with. So we need to start with our function 4y minus x equals 20. We need to find the slope of this line, the line that goes through this relationship, has this relationship. So we got to get it in the right form. So let's move the x to the other side. And so we got x plus 20, divide everything by 4, and we found our slope. Our slope is 1/4. Now we don't need the y-intercept in this case. What we need is that slope right there. So we need we need an equation that has slope 4 and passes through the point 2, minus 3. So we go back to y minus y1 equals m times x minus x1, and we plug in this particular point here. So we go y minus the minus 3, our slope is 1/4, and x minus 2. A little bit of algebra will get us to a slope-intercept form of this. You get 1/4 x, all right, and then 1/4 times minus that, that's a minus 1/2, and then this is a plus 3, but when we bring it over, it's a minus 3. So be careful with those negative signs. So you get y equals 1/4 x minus, now this is 6/2, so that would give us minus 7/2. You can use your calculator to help you with those fractions if they were giving you any kind of trouble. So this is our solution to part A. This is a line who's parallel to our original line. They both have the same slope of 1/4. This has a slope of 1/4. This has a y-intercept of 5. This has a different y-intercept of negative 7/2. So on part B, we're looking for the perpendicular line. Now the perpendicular line is going to have a negative reciprocal slope. So our slope is going to be -1 over the original slope. -1 over the original slope. So that flips up and becomes -4. So we're looking for a line that has slope of -4, and again, it still passes through the point 2 comma -3. So we do our y minus y1, so use this formula right here again. So y minus y1, that'd be -3, just like before. But we have a different slope now. Our slope is -4, and we go x minus 2. A lot of the algebra is the same, except we have a different slope right here. So let's do all the algebra once here. So you got -4x. You get a positive 8 over here. You get a positive 3 over here, but you subtract it over to the other side, and so you get a positive 5. And so this is a line who's perpendicular to this original line, 1/4 x plus 5. This is -4x plus 5. They happen to share the same y-intercept, which is cool, which is interesting, and they have the perpendicular slope, this one and this one.